number IP-NO-2020-2-N00471, water quality certification and coverage under the WPDES general permit number WI-S067831-06, issued to Enbridge Energy LP and the Department of Natural Resources Environmental Impact Statement for Enbridge Energy's Line 5 segment relocation project in Ashland, Bayfield, and Iron Counties. The DHA case number is DNR-25-0002, and the DNR case numbers are 24-048 and 24-049. We are in person at the Hill Farm State Office Building in Madison. Additionally, there is a Microsoft Teams video feed of this hearing. I'm going to ask the parties, like we do each morning, to state their appearances, starting with your gestures, please.
Good morning, Your Honor. Attorney Anya Jansen, appearing on behalf of Sierra Club, League of Women Voters of Wisconsin, and 350 Wisconsin. I'm joined by Attorney Rob Lee and Attorney Skylar Harris.
Good morning, Your Honor. Brett Cordy, attorney with Clean Wisconsin on behalf of Clean Wisconsin, and I'm joined by my colleague, Evan Feinauer.
Good morning, Your Honor. Stephanie Sosi on behalf of Bad River Band of Lake Superior, Chippewa. With me at council table are Bob Lindbergh and John Patowski.
Good morning, Judge Foy, Attorney Michael Kowalkowski for the Department of Natural Resources, joined by attorneys Catherine Hansen and Craig Sparks.
Attorney Kowalkowski, do you want to pass the microphone? Thank you.
Thank you. Good morning, Your Honor. My name is Nick Kovac, attorney with Foley & Lardner, representing the permittee Enbridge Energies LP. Here with me at council table is attorney Eric Mawson, as well as attorney Thomas Hutchison, as well as our paralegal Heather Hedry and in-house counsel Shannon Benzer.
Good morning again to you all. Just touching base, a reminder in case you haven't been here in person before, a little reminder of our rules for those watching. I appreciate your interest in terms of decorum. I just ask that nobody disrupt the proceedings. If you do disrupt the proceedings, anything that interrupts it, we'd be asked to leave. Members of the media or anyone taking videos or photography, again, I appreciate your interest, but I ask as you do your job not to be disruptive, and a reminder that no pictures or videos may include any of the computer screens or items on council table or on the tables up here at the staff. We concluded yesterday with Dr. Allmendigger's testimony, and I understand that we're moving on to the next and final witness, potentially, from the environmental petitioners, but anything to address before we charge testimony this morning?
Nothing here, Your Honor.
Haven't heard of it.
Nothing from the department.
Okay, then your next witness, please.
Thank you. Environmental petitioners at this time call Tracey Ledder to the stand.
I'm going to ask you to pull the microphone close so that we can try to pick up as much as we can. Please raise your right hand. Do you swear to tell the truth, the whole truth, and nothing but the truth?
I do.
Please state and spell your full name for the record.
Tracey Ledder, Tracey Ledder.
And where are you employed?
Delaware Engineering in Albany, New York.
Thank you. Please go ahead.
Good morning, Ms. Ledder. Have you ever served as an expert witness in a legal proceeding? What matters were you asked to opine on for this case?
Matters relating to water quality impacts and the adequacy of the water quality monitoring plans for determining impacts.
And did you reach opinions in these matters? Did you prepare any materials as an expert witness for this case?
Yes, I prepared an expert report and compiled testimony as well as one display.
We're going to pull up a document to display on your screen. Do you recognize this document, which has been pre-marked as Exhibit 102?
Yes, I do.
What is this document?
This is my expert report.
Does your expert report contain a copy of your CV?
Yes, it does.
Can you please briefly describe your educational background?
I hold a Bachelor of Science in General Biology from Binghamton, New York, and and a Master of Science in Environmental Science and Engineering at Virginia Tech.
I'm gonna ask you to pull the microphone closer, we're not picking it up through your microphone.
And maybe I need to raise it a little bit. Does that work?
Can you please briefly describe your professional experience?
I have 30 years or more of experience in environmental assessment and water quality monitoring. That involves work for the state of Virginia in their Superfund department, the state of New York in the Department of it's actually the Bureau of Watershed Protection in the Department of Environmental Conservation, oversight on New York City drinking water system. And in the state of the state of Wisconsin, I worked as the St. Louis River Area of Concern Coordinator and at the National Estuarine Research Reserve as Monitoring Coordinator. I've also worked for several consulting firms. Prior to my current, that was largely phase 1 and phase 2 environmental assessments for commercial properties, mold assessment from water damage, leaking underground storage tank, petroleum site contamination sampling, and various other tasks that they came up.
Can you please describe your roles and responsibilities in your current employment?
Currently, I am Senior Environmental Scientist for Delaware Engineering. Is that okay? Delaware Engineering that specializes in wastewater and drinking water systems. They go through the whole process from evaluation of current issues with discharge permits or operations, design and engineering for fixing those problems or allowing for expansion of discharge or drinking water supply. They oversee construction. We apply for grants. Most of our clients are small municipalities. I support the engineering aspects with the science side of things, collecting samples for analysis for discharges or compiling historical data for permit applications. I've sampled drinking water reservoirs and wastewater treatment plants. I also do wetland delineations for construction projects related to those systems. Anything else that comes up actually that's involving science, I get to do. I've done environmental impact statements, preliminary engineering reports, and also consolidation of drinking water and wastewater treatment districts, as well as analyzing the financial aspects and creating rate structures.
And during the course of your career, have you ever worked within the Bad River watershed?
Yes, I have.
Can you please describe some of that work?
I was the water resources specialist at the Bad River Band for 4 years, and another 3 years after that I worked with them in their water resources department and as wetland technician. I also helped set up the Bad River Watershed Association, which is now Superior Rivers Watershed Association. I helped set up their citizens monitoring program.
Did you conduct water quality monitoring within the Bad River watershed during the course of that?
Yes, both of those, all of that involved going to streams, sampling streams year-round. We also looked at the chemistry, the basic health of the watershed, biology. I taught community science volunteers how to identify macroinvertebrates as an indicator of watershed health. And we also made observations of the physical aspects of stream health and culverts and other potential impacts.
Does your expert report describe the opinions that you've reached in this matter? Does it also contain the bases for those opinions?
Yes.
Environmental petitioners would now move Exhibit 102 into the record.
No excuse me, no objection.
No objection.
102 is received.
Ms. Ledder, did you prepare pre-filed written direct testimony for this matter?
Yes, I did.
We're going to display another document on your screen. Do you recognize this document?
Yes.
What is it?
This is my pre-filed direct testimony.
Does this testimony further establish the opinions that you've reached in this matter?
Yes.
Does your pre-filed testimony respond to any expert reports filed in this matter?
Yes.
Environmental petitioners would now move Exhibit 128 into the record.
No objection.
No objection.
128 is received.
Did you review any of the project permitting materials in preparing your expert report and pre-filed testimony?
Yes, I did.
We're going to display another exhibit here. Do you recognize this document?
Yes, I do.
And what is this document?
This is the water quality monitoring plan for the proposed project.
Is this one of the documents you reviewed?
Yes, it is.
We're going to scroll to attachment 6 of Exhibit 829 at page 162. Ms. Ledder, do you recognize this part of the exhibit?
Yes, I do.
And what is it?
This is the quality assurance project plan that goes along as part of the water quality monitoring plan.
Can you please explain what a quality assurance project plan is?
The quality assurance project plan of many field sampling projects is that document used to define the objectives, the reasoning behind the data collection, and provide for a means of assuring that the data collected is of the quality needed to meet the objective. Does it answer your question? Are your detection limits appropriate for any laboratory analyses decided upon to meet those objectives in the field? What are the responsibilities of personnel involved in the project in terms of assuring data quality? Who is going to be validating data using what means and what information? How are collected data, once the quality of that data is assured, how is it interpreted? Methods used, uncertainties. Basically, it details those steps and responsibilities needed to make sure that the data is of quality and able to do what you've asked of it.
Did you rely on any sources outside of the project permitting materials in forming your opinions?
Yes, I did.
Does your expert report contain a list of those sources?
Yes, it does.
And did you also rely on those same sources to prepare your pre-file testimony?
Yes.
We're going to display another exhibit here. This has been pre-marked as Exhibit 103. Do you recognize this document?
Yes, I do.
What is it?
This is a document written about the characteristics of the red clay plain, that northern area in Wisconsin along Lake Superior, its history, and some of the reasons for which it is much more susceptible to erosion because of its soils and geology and history, and ways in which that impact from erosion can be prevented when human activities occur on the land.
Is this document cited in your list of references of your expert report?
It is.
Okay, a few more here. We're now going to display an exhibit pre-marked as 105. Do you recognize this document?
Yes, I do.
Can you please describe this document?
This is a safety data sheet for one of the chemicals that's a possible drilling fluid additive. A safety data sheet spells out the chemical properties of a particular chemical and talks about some of the hazards of its use, personal protection, ecological toxicology of that chemical.
And did you cite to this document in your expert report?
Yes, I did.
Environmental petitioners would now move exhibits 103 and 105 into the record.
No objection.
No objection.
103 and 105 are received.
Okay, next we're going to display a document that's been pre-marked as exhibit 118, subparts A through D. Do you recognize this document?
Yes, I do.
Have you had the opportunity to review this proposed exhibit before today?
Yes.
Can you please briefly describe what is contained within this document?
This is a compilation of several of the documents that I used outside of the project documents in my recorded testimony.
And are these documents included in that list of references cited?
Yes, they are.
Ms. Ledder, did you form an opinion on whether Enbridge and DNR have sufficient information to fully evaluate project impacts to water quality?
Yes, I did.
What is that opinion?
As written, the monitoring plan does not provide allowance for sufficient data to determine whether or not there is an impact to this project. Therefore, there's not sufficient data to have an assurance that there won't be an impact.
Did you form an opinion on the adequacy of the baseline water quality data that Enbridge and DNR rely on to assess project impacts?
Yes, I did.
What is that opinion?
The baseline data provided is inadequate for the proposed project route, as a large majority of the historic data is not within the project route, as well as the two samplings, one in 2023 and one in 24, are insufficient to describe sufficiently baseline data for the majority of those smaller streams and wetlands along the route that have never been sampled before.
And did you form an opinion on the sufficiency of the water quality monitoring plan and the quality assurance project plan?
Yes, I did.
Can you please state that opinion?
The water quality monitoring plan and the quality assurance plan are insufficient in terms of stating objectives, outlining data collection needs, reasons for sampling of each parameter, quality assurance objectives for laboratory analysis, data validation, and any specific methods spelling out how that data is going to be used to interpret situations.
Have your opinions changed for any reason since you filed your expert report and pre-filed testimony?
We have not.
I want to start by going over water quality data. First, can you please describe what a water quality parameter is?
Water quality, a parameter, is a term used to describe the one thing that's being measured. In terms of water quality, you could think of it as if you're going to the doctor's for a checkup. The first thing they do is they take your temperature. They may take your blood pressure. Those are some really basic parameters that a doctor would look at in terms of human health to decide, in general, how you're doing. That relates to some of the basics, common water quality field parameters, such as dissolved oxygen or pH or temperature or turbidity. Those are parameters that are measured directly in the field and are used to give a good indication of what the quality of the water resource is.
Can you give an example of how data would be collected for a certain water quality parameter?
Depending on the parameter, it could be measured with a field reader, which is usually some sort of an electronic device. It depends on exact details depending on the parameter. That can be inserted directly into the water column, and results can be read on a small screen and somehow documented after that. Many water quality parameters of interest to a specific project are things that need to be taken from the stream, either in a bottle collected with a sampling device or direct take into a bottle, dipping it into the water and taking it to the lab. And the lab needs to analyze that, much more specific details on getting that analysis done.
Is understanding the concept of baseline water quality important to the opinions that you reached in this matter?
Yes, it is.
And can you please explain what baseline data means?
Baseline data in general is a longer-term record encompassing the variability inherent in any parameter. In terms of water quality, that's usually considered to be several years across several seasons to enable to encapsulate what happens when there's a dry season, when there's a rain event, when it's a cold year, when it's a warmer year, changes in vegetation. What is the range of what you expect to see in that particular parameter?
Is establishing baseline data necessary for assessing potential project impacts to water quality?
Yes, it is. The area or the particular water body that may experience an impact on any one project, you can't necessarily determine whether there's an impact if you don't understand baseline. Baseline encompasses that natural range and variability inherent in different seasons and different circumstances that that water body might see. So baseline is important in the understanding of what is expected as normal for that particular water body in order to determine if an impact has occurred.
Do Enbridge and DNR rely on baseline water quality data to assess potential water quality impacts for this project?
Yes, they do.
What comprises that baseline water quality data?
The baseline data is got two different parts in it, as presented in the monitoring reports and the expert reports. Baseline data is available for many of the streams across the watershed, the Bad River watershed as a whole, from different gauges, either USGS gauges, some of the bands sampling, some other agencies that may have sampled, and that's been pulled together to get an idea of what the historic range of things are across the watershed. Enbridge has also done one sampling round of all of the specific sites upstream and downstream that they would be sampling during construction. As a pre-construction sampling, they did that in 2023 and again in 2024.
We're going to display another document on your screen. This is Exhibit 830. Do you recognize this document?
Yes.
And what is this document?
This is a water quality monitoring report.
Did you review this document?
Yes, I did.
We're going to next display Exhibit 119. Do you recognize this document?
Yes, I do.
And what is it?
This is the second water quality monitoring report.
Did you review this document?
Yes, I did.
Do both of these reports describe the baseline water quality information that Enbridge and DNR rely on?
Yes, they do.
In your assessment, is the historical data that Enbridge and DNR rely on adequate to establish a baseline for this project?
In my opinion, it is not.
Why not?
The historic data collected across the watershed by various agencies in the last 10 years or so is not necessarily at the root, the proposed root, would not be describing the water resource in that area of the stream. The sampling data in 2023 was taken in September and October. Sampling data from Enbridge taken in 2024, I believe, was in May and June. Therefore, they have not had more than 2 sampling points. It's really not enough to establish the long-term record of a baseline potential variability.
In your opinion, do Enbridge's 2023 and 2024 water quality sampling data taken together with the historical water quality data constitute an adequate baseline for assessing project impacts to water quality?
No.
Can you please explain why not?
The water quality monitoring plan requires that during construction, in order to determine an impact, samples would be taken upstream of where the pipeline crosses any particular water body and downstream. The data that they have collected at those sites is not enough to describe the natural situation there. So if you had a difference between your upstream sampling and your downstream, that would possibly reflect an impact, but there's no decision matrix in that monitoring plan to say how much of a difference is significant, and they don't have enough data for baseline for that particular stream at that site in order to determine that difference.
Ms. Ledder, did you prepare any additional exhibits as part of your pre-filed testimony that were not in your expert report?
Yes, I did.
We're going to display a document on your screen that has been pre-marked as Exhibit 118, Subpart E. Can you please read aloud the title of this document?
Histograms of water quality data on variability.
Can you please describe generally what a histogram is?
A histogram is a general graphing tool that helps anyone visualize what that data set looks like. Another common graphing tool would be a data timeline. Across the bottom would be the dates that were sampled in sequence, and you could see how the data fluctuated across time sequence. A histogram is more of a stacked data look at that data. You could think of it in terms of going to a shoe store and wanting to know what size shoes were there. You would stack each shoe size in a comparable stack by number. If women's shoe size average is 7, the central tendency of that stack would be the average shoe size at 7. And then on each side of that, the sizes would be getting smaller. There would be fewer numbers smaller so that that line drops down. And then there's fewer numbers of sizes that are, of boxes of each size that are larger so that line drops down to the other side. And that's like a lot of water quality parameters in which the central tendency is the one most measured, but there are different numbers that are either above that or below that that you would expect to see depending on the situation in the site.
Are histograms a standard tool used in your field of environmental assessment and water quality monitoring?
Yes, they are.
Is it a tool that you often use when examining a data set?
Yes.
Did you prepare this proposed exhibit?
Yes, I did.
Can you please explain how you prepared it?
Using several publicly available educational images and pulling data from the USGS stream gauge at the Bad River near Rodana, which is also publicly available. I put that data into Excel and utilized that to create several histogram size examples.
And finally, why did you prepare this exhibit?
I thought it was important to show how I believe the data should have been treated and the number of circumstances where different parameters are discussed.
Did you prepare this exhibit in response to any expert reports filed in this matter?
Yes, I did.
Okay, we're going to zoom in a bit on page 172 of Exhibit 118. Can you please describe the data that is displayed here in this first histogram example?
This is an example of what's called a normal distribution. As we were talking in the situation in the shoe store, that average value in the center is the highest point of the peak. That's called the central tendency. A real common measure of the central tendency is the average. To calculate an average, you add up all the different values that you have and divide them by the number of samples that you have. That's the average. Another measure of central tendency is the median, which is the 50th percentile. If you put all of those data values that you collected, starting from smallest to largest, and you went to the 50th percentile, that data point in the middle, that's the median. And the other common one is the mode, which is simply the number that's most often repeated in the data set. In a normal data distribution, you see that central tendency peak at the top, the mean, the average, and the mode are all there at the top together. As the data values commonality falls off, you get fewer and fewer on the smaller value side that slopes down and goes out. Same thing on the other side to where the higher values, and those are equally distributed. A measure of that helps you understand data if you're discussing it with other people who haven't been part of your project. You would say, here's the average or the median or the mode, this is the central tendency. You would also describe the standard deviation and how much of the data fits outside of that central tendency. In this example, it's not giving you particular data, it's just showing you that one standard deviation on either side of that central tendency is going to encompass 68% of the data. So if you know that one standard deviation is so many numbers away from your average, you get an idea of how wide that data is spread, how wide that range is. Two standard deviations on either side of the center are going to, and this is at the top of this graph here, are going to encompass 95% of the data. And then 3 standard deviations, we'll talk about 99% of that data set. So explaining to someone what's the center the central tendency and what is the standard deviation is going to give someone a good idea of what that data set looks like, how variable it is.
Do the central tendency and standard deviation for a normal distribution provide an idea of natural variability of the data set displayed?
Yes, the use of the central tendency, usually the average, and the standard deviation gives you a broad idea right off what the variability is.
Is it typical for water quality data to be normally distributed?
No, it's not.
How would water quality data typically be portrayed if it displayed on a histogram?
Normal, a lot of them, not all of them, but a lot of the normally measured water quality parameters are what we call skewed. The central tendency is either to one side along the smaller values, and it might tail off to higher. And that's true on several parameters. If, for example, that parameter measures as much higher during a storm event, most of those monitoring results are going to be up to the left. They'll be smaller values, but those higher values shown in the storm event will be part of the tail. In that case, the central tendency is not best measured by the mean, and it doesn't have that nice bell-shaped curve of a normal distribution.
Ms. Ledder, I noticed you were gesturing a lot. If we scroll to the next page of Exhibit 118 on 173, do these images help you explain what you just described?
Visuals always help. Yes, this central graph here is the normal distribution we were just looking at. On either side of that are two examples of skewed data. It can be negatively skewed, where the tail goes off to the lower values, or on the right side, it's positively skewed, where that central tendency is closer to the left and the tail goes out to higher values. And yeah, this graph is good in showing you how that mean, median, and mode in the central normal distribution are all the same value. You could use either one of those to describe that central tendency. However, in the skewed data, the mode is the number that's most commonly seen in that data set. So that's at the top of that peak, where that's the most values are that number. The numbers start lower and go higher across the bottom of that axis. The median at 50% of that data values is showing where 50% of the data is less than that value. And the mean is showing you what's the total value divided by the number of samples and the average. You can see on this that mean is particularly pulled out to the tail. It's a much more influenced by higher values at the end of the tail than the median or the mode.
And would you use the mean and standard deviation to analyze a skewed data set?
No. The standard deviation of a skewed data set, standard deviation doesn't take into account the shape of that skew. So what's commonly used for a skewed data set is the median and the first quartile, which is the first 25% of data on the lower values, and the 75th percentile, which encompasses 75% of the data.
How would using the mean and standard deviation for a skewed data set impact the characteristic of natural variability?
Depending on how skewed it is, the more skewed, the more inflated that variability would appear.
Okay, Ms. Ledder, we're going to display another document on your screen. Do you recognize, oh, sorry. Do you recognize this document, which has been pre-marked as Exhibit 376?
Yes, I do.
What is this document?
This is direct testimony of Dr. Matt Horn.
Did you review this pre-filed testimony?
Yes, I did.
Did Dr. Horn discuss baseline water quality data in his pre-filed testimony?
Yes, he did.
We're going to scroll to page 12. Can you please read aloud lines 6 through 9?
Two key findings of the water quality impacts assessment are: 1, the robust amount of data collected for each water quality criterion of concern, providing sufficient data to quantify both intra and interannual variability for each parameter, and 2, the recognition of a large amount of natural variability in each water quality criterion assessed.
Based on your review, how did Dr. Horn measure the central tendency of the water quality data he says show a large amount of natural variability?
Dr. Horn used the mean and the standard deviation.
In your opinion, would that be an appropriate measure by which to describe natural variability of these water quality parameters?
Not for all of them.
Why not?
Again, a lot of the parameters that are regularly measured for water resources, especially those in the field, are not normally distributed. They're skewed.
And does using the average data point to measure the central tendency of water quality data impact how the natural variability of that data set is interpreted?
Yes, usually you give the range, what was the minimum and what was the maximum, but if you're using the mean as the central tendency and a standard deviation to interpret that variability, it can be highly inflated depending on how skewed that data is.
Does Dr. Horn describe natural variability for each water quality parameter at specific sites along the project route?
No, he does not.
On what scale does he describe natural variation?
In his report, he describes natural variability on a watershed-wide scale on all of the data sets that are in the historic data set and Enbridge's.
What do you mean by watershed-wide scale?
A watershed-wide scale in a data set means that data has been collected across many different types of water bodies in different locations along each water body. Larger streams, smaller streams, intermittent streams, ephemeral streams, and wetlands, all of which have very different characteristics. And most streams have different characteristics upstream when there's less flow than they do downstream. So one historic site, 10 years data, does not necessarily describe the characteristics of that stream further upstream or further downstream.
So in your opinion, is a watershed scale appropriate to establish natural variability of each water quality parameter assessed for this project?
No, it does not, because the water quality monitoring project plan requires during construction, and so because it's required during construction, they also sample pre-construction and will be sampling post-construction upstream and downstream of the project's crossing of each different water body. But without having a good baseline of data for each of those sites and without any criteria for determining what the significant difference is between that upstream and downstream, there's no way to determine impact.
Based on your review of the baseline water quality data and analysis, did DNR have enough information to fully evaluate impacts to water quality for this project?
No.
Can you please elaborate?
Because the baseline historic data set is taken at multiple sites that have been sampled multiple times, but they are not along the proposed route. And Enbridge's data set is of 2 samplings, one in May, June, and one in September and October, which is would not be considered a complete baseline data set either.
Let's turn to some specific water quality parameters. Starting with surface water temperature, is this one of the water quality parameters assessed for the project?
Yes.
Could a change in surface water temperature impact the water quality at any given sampling location?
Yes.
Can you give an example of how that would impact water quality?
Many of the animals, from algae and bacteria to macroinvertebrates to small fish to larger fish, have preferences for a particular temperature range. And a change in temperature might affect their use of the habitat.
In his pre-filed testimony, did Dr. Horn offer an opinion on potential project impacts to surface water temperature?
Yes, he did.
Can you please describe your understanding of what that opinion is?
His opinion is that any impact caused by construction to the temperature parameter would be local and short-term.
In his pre-filed testimony, did Dr. Horn offer an opinion on the natural variability of surface water temperature?
Yes, he did.
What is your understanding of that opinion?
That there is a lot of temperature variability across the watershed.
In your opinion, is assessing natural variability on the watershed scale useful for determining project impacts to surface water quality?
Not on for the project, no, because what is being assessed and sampled is the upstream and downstream of each particular project stream crossing. And baseline data has not been established on either one of those particular sites. So the data variability across the watershed is not going to help you determine whether there's an impact at a particular site.
And based on your review, what measure does Dr. Horn use to assess the natural variability of surface water temperature?
He uses an average.
Okay, we're going to pull up Dr. Horn's testimony, to which you previously testified, and turn to page 17. Will you please read aloud lines 18 through 22?
Unsurprisingly, waterways in northern Wisconsin experience large seasonal temperature fluctuations, with lowest recorded temperatures of approximately 32 degrees Fahrenheit, the minimum temperature of liquid water, and the highest recorded temperatures of approximately 82 degrees Fahrenheit. This is an annual temperature range exceeding 50 degrees Fahrenheit. Large temperature fluctuations were present at all water bodies sampled.
We're going to now turn back to Exhibit 118E on page 175. Can you please describe the data that we're looking at here?
This is from the histogram display that I created, and again, it is the USGS gauge at the Bad River near Odena. This is the data sample set for temperature from 2010 through 2024. At the bottom of the graph, you can see N equals 160. That means the number of data points is 160. As spread across this histogram, a large number of those temperature data points was 0 to 1, 25 up against the left, and then another large set was almost 20, up by 19 to 20, and this is degrees in Celsius.
Ms. Ledder, is this surface water temperature data displayed on the histogram assessing water quality on an annual basis?
Yes, it is.
How would you typically analyze water quality data for surface water temperature?
Because of the extreme difference between, especially in northern Wisconsin, between winter colds and summer warms, it's normal to divide this winter and summer season and look at that data separately.
We're going to scroll to the next page, 176. Can you please describe the data now displayed on your screen?
This is that same data set from the previous histogram divided into the summer data histogram and the winter histogram. And again, in the summer, you can see the central tendency, and at the bottom again, there's 113 points that I divided as summer between June and November, so that the median or the central tendency there is approximately 20 at that highest peak, and it falls off to the warmer side at 26 to 27 degrees Celsius, and tails off to 0 degrees at the lower end. And those tails are likely because of the way it was divided. In June, beginning of June in northern Wisconsin, you can still be getting cold nights and cool days. And then again in November, you're definitely getting into colder nights and cool days. So those temperatures extremes of lower are normal to see temperature ends at the higher end would be that summer. And then again for the winter it's similar. 25 of those data points of 47 winter data readings are between 0 and 1 degree Celsius. That's the central tendency, and you've got a lot of just tailing off to those higher temperatures, probably because of those seasonal changes at the ends of that month, beginning of November and end of May. But central tendency is definitely very cold.
Based on your review, did Dr. Horn analyze surface water temperature on a seasonal basis like you've just described?
No, he did not.
Based on your review, did Dr. Horn accurately portray the natural variability of surface water temperature?
No.
Why not?
Using the annual variability to describe the very natural variability of temperature is inflating the natural variability, and it's not useful for using baseline data to determine an impact at one site at one time of the year. We need to be talking about the appropriate seasonality of temperature.
Let's turn next to dissolved oxygen. Is dissolved oxygen one of the water quality parameters assessed for this project?
Yes, it was.
Could a change in dissolved oxygen impact the water quality at any given water body sampled?
Yes, it could.
How so?
Dissolved oxygen is one of those parameters that we measure that many of the aquatic organisms, small macroinvertebrates, fish, other things, and actually vegetation affects dissolved oxygen as well. A lot of those animals that use a water body depend on different ranges of dissolved oxygen, especially trout that are very sensitive, and several of the macroinvertebrates that trout feed on are also very sensitive to changes in dissolved oxygen.
And did Dr. Horn opine on the natural variability of dissolved oxygen in his pre-filed testimony?
Yes, he did.
What is your understanding of that opinion?
That across the watershed, there's a lot of variability in dissolved oxygen.
For dissolved oxygen, is it helpful to know the variability throughout the watershed when assessing potential project-related impacts to dissolved oxygen?
No, it does not. If the project is crossing a wetland or otherwise impacting a wetland, you would expect to see a much different dissolved oxygen regime at that one particular site, or a moving stream of different sizes, small stream, moderate stream. You would expect at that particular site to have its own particular natural range of dissolved oxygen.
We're going to display Dr. Horn's pre-filed testimony again. We're on page 23. Can you please read aloud the full sentence beginning on line 15 and ending on line 16?
Overall, DO, dissolved oxygen, levels naturally varied from 0.64 to 89.90 milligrams per liter.
We're going to pull up a different document now. This is Exhibit 304. Ms. Ledder, do you recognize this document?
Yes, I do.
What is it?
This is Dr. Horn's expert report.
Did you review this report?
Yes, I did.
Turning to page 47, can you please read aloud the heading for section 5.3.1?
Background levels and natural/seasonal fluctuations in dissolved oxygen.
Can you please read aloud the very last sentence on this page?
It should be noted that maximum values from historical measurements and Enbridge may be associated with sampling or measurement problems, extreme production, aeration by turbulence, for example, rapids or waterfalls, or other unknown source, as they would be associated with oxygen saturations that would be several-fold greater than equilibrium.
Can you please describe what saturation means with respect to dissolved oxygen concentrations?
Saturation is a term often used when dissolved oxygen readings are being compared across water bodies or for the same water body under different temperature regimes. Dissolved oxygen is a gas, and it doesn't act as other things that we're used to discussing dissolved tendencies in. You can think of tea, iced tea, and you're putting your sugar in and stirring it up and the sugar dissolves. Hot tea, you put your sugar in and stir it up and the sugar dissolves. Hot tea is much more capable of dissolving more sugar than the cold tea. And sometimes on a summer day, if you're drinking your iced tea, you'll notice a little sugar precipitated out at the bottom. Dissolved oxygen is the opposite because it's a gas. So a gas, when it's heated, tends to move around a lot more. The molecules are more excited. And in that case, dissolved oxygen would leave the water column if the water temperature is raised. So the measure of percent saturation is used to discuss dissolved oxygen at different sites in different times, or same site in different time. An atmospheric pressure relates to this too, how much dissolved oxygen can dissolve at any one water, at any one temperature and atmospheric pressure. So if we know what that is, so when you take that reading, especially on the field meter, you would get, here's your dissolved oxygen in milligrams per liter, and you would also get what is that percent saturation. So looking at percent saturation, you can tell how you can use that percent saturation in many cases across different water bodies and different times of year to assess the health of that water body. Really low numbers means it doesn't have enough oxygen for specific types of fish. Below 2% is considered anoxic. You don't really have enough dissolved oxygen. Regularly, 80% of those types of levels is common to see as well.
Do you have a response to Dr. Horn's statement that maximum values of dissolved oxygen are associated with oxygen saturations several-fold greater than equilibrium?
Yes. His response includes the fact that you can supersaturate oxygen. Anything that tends to add oxygen to the water column, like strong winds or a waterfall where the water falls over rocks and goes through the air before it falls down, that can add more oxygen to a particular water body, and it might have more than 100%. However, 89 milligrams per liter is way above saturation for any natural water body, and it's probably in error.
In your opinion, should Dr. Horn have continued to rely on those maximum values for dissolved oxygen in his assessment of natural variability?
No, I don't think it's appropriate. In my experience, it could have been some sort of a data misdocumentation or a transcribing error where you read the monitor, you read your meter, and you read milligrams per liter, and you read for percent saturation, and whoever wrote it down switched them, because 89%, 70 some odd percent saturation makes more sense than 89 milligrams per liter. So I believe those high ends are most likely percent saturation readings and not concentration readings, whereas that data shouldn't be used to describe your dissolved oxygen concentration data set.
In your opinion, did Dr. Horn's continued reliance on those values impact his characterization of natural variability for dissolved oxygen?
Yes, it did. There's a handful of data points that are way above what's possible for the concentration of dissolved oxygen at milligrams per liter, and those data points should not have been used.
And how did that impact his assessment of natural variability?
It extremely expands the range of dissolved oxygen readings and inflates variability.
Okay, let's next discuss pH. Is pH one of the water quality parameters assessed for this project?
Yes, it is.
Could a change in pH impact the water quality of any given water body sampled?
Yes, pH is one of those natural components that anything living in that water would experience, and several aquatic organisms have preferences for pH.
Did Dr. Horn opine on the natural variability of pH in his pre-filed testimony?
Yes, he did.
What is your understanding of that opinion?
That pH values are very variable across the watershed.
Do you agree with that assessment regarding variability of pH across the watershed?
Well, in general, yes, across the watershed, pH is expected to vary a lot. On a daily basis, a watershed has those samples in the historic database are taken from wetlands and small streams and large streams and streams that are flowing more than others and some that are not. pH in any one of those can vary over the day and is expected to, but the variability encompassed across all of those water body types is not relevant to a single site.
So in your opinion, is it useful to assess natural variability in pH at the watershed scale if the goal is to assess project impacts?
No, it's not. Again, the monitoring plan requires a sample during construction upstream and downstream to determine if there's a significant difference, but using the baseline for an entire watershed data set is not relevant to what's necessary for understanding baseline and natural variability at each water body in order to decide, has there been a change or significant difference? And the Water Quality Monitoring Plan and Quality Assurance Project Plan don't describe what's the criteria to decide if there's a significant difference.
Looking again at Dr. Horn's testimony in Exhibit 376, we're on page 27. Can you please read aloud the last sentence beginning on line 19 and ending on line 21?
Of note, natural pH changes of up to 0.23 within a single hour were observed during water quality sampling of the Bad River near the Meander Bank Stabilization Project site.
And based on your experience, does a change in pH of 0.23 signify high variability in pH?
Not in my experience. Sampling rivers, you've got flowing water. That flowing water is impacted by lots of things, including vegetation and algae. Vegetation and algae are photosynthesizing during the day, and the more that happens, the higher the pH value might get. So during the day, you're expecting to see pH values rise and lower, and flowing water is just going to fluctuate. So that's not an unusual variation.
In the testimony you just read aloud, Dr. Horn refers to the Meander Bank Stabilization Project site. Are you familiar with the site of the meander on the Bad River?
Yes, I am.
We're going to pull up a map here. Do you recognize the map on display?
Yes, I do.
Can you please describe this map, which has been pre-marked as Exhibit 201?
This is a map showing the ecoregions of the Bad River Reservation. Bad River Reservation, the Bad River watershed, and some of the surrounding areas. And it also shows the water bodies.
What does the red line shown depict?
The red line, as shown up in the legend up on the upper right, is the existing pipeline as it crosses the reservation and across northern Wisconsin.
And what about the yellow or orange line? What does that depict?
That line shows where the proposed route for the Line 5 replacement route deviates from the current route and south along the outside boundary of the reservation to join its point up again on the other side.
If we zoom in here slightly, can you indicate where the meander site is on this map?
You can see the blue line that goes from the southern end of the reservation up to the north is labeled the Bad River. So that line that's kind of curlied and very, it's not a straight line, it's a meander. At where it meets that red line is known as the meander, and that's where the pipeline crosses.
Does Enbridge plan to cross the meander site with the proposed reroute?
No.
In your opinion, is a pH value at the meander site representative of natural variability of pH along the proposed project route?
No, you can see where the proposed route yellow line crosses the Bad River down in the vicinity of Mellon at the bottom of this map. In between the Bad River at Mellon and the Bad River at the meander, there are many tributaries of different sizes joining the Bad River. So the Bad River's flow is extremely different. Its stream bed is probably different as well. And the characteristics of the Bad River at the meander are going to be very different from the characteristics of the Bad River at Mellon.
Okay, one final water quality parameter. Is total suspended solids, or TSS, one of the water quality parameters assessed for this project?
Yes, it is.
Could a change in TSS impact the water quality of any given water body sampled?
Yes, different water bodies can have an impact.
Can you give an example of what a potential water quality impact might be?
Total suspended solids are usually soil, particulate matter, sands or silts or various sizes of each of those. They tend to settle out in the water body, depending on how much flow there is at different distances. Some of the small streams can be more susceptible to that sediment from an impact settling out on the stream bed and covering habitat for macroinvertebrates and small fish.
Did Dr. Horn offer an opinion on the natural variability of TSS in his pre-filed testimony?
Yes, you did.
What is your understanding of that opinion?
That suspended solids is quite variable across the watershed.
Would you consider natural variability assessed on a watershed scale suitable for determining project impacts to TSS?
Not for the project impact determination, no.
Why not?
Again, the monitoring plan requires sampling at a single site, the upstream of the pipeline crossing of that water body and the downstream side, and comparing those and looking for a significant difference. A significant difference can only be determined if you know what the natural variability is of that water body, without having a good understanding of what's naturally seen at that river and that particular site. You can't make a determination of whether any difference is significant or not.
And based on your review, how did Dr. Horn measure the central tendency of TSS water quality data when assessing its natural variability?
He used the mean and standard deviation.
Do you consider that to be an appropriate measure of natural variability for total suspended solids?
No, I don't.
We're going to pull back up Exhibit 118, Subpart E, and we're on page 174. Can you please describe the data set that's displayed on the screen?
This again is that data set from the USGS gauge for the Bad River near Odana. The data in this for TSS was between 2011 and 2023. At the bottom there, N equals 241. There's 241 individual data readings that are stacked in this histogram. You can see the central tendency is very much up to the left. It's highly skewed data. Down here on the chart at the bottom, you can see that the median is 30 milligrams per liter. That, okay, across the bottom, on the lower axis are bins. The first bin is 2 to 22 milligrams per liter. The second bin that's described, and again, it's kind of difficult because they don't have enough room to put every single bin titled or labeled. The next bin that's numbered is 122 to 142. So the median of 30 milligrams per liter is just past the very left bar there. The 75th percentile is the number of which data points, 75% of the data is lower than that. That is about 3 bins over. However, the average is 254.2, which is past the third bin or in that third bin, as the average, and the standard deviation is 560. Both the average and the standard deviation are extremely impacted by the wide range we see here. The range goes from 2 to 4,582, but you can see that this is very highly skewed data. The majority of the data points are below 239.5, and several single data points across this data set really impact that skew. So those might have been storm events, they might have been rain events, it might have been snow melt, we don't know. But it's not unusual to see total suspended solids data with this amount of skew.
Given what you've just described, would the mean and standard deviation be an appropriate measure for describing natural variability of this TSS data set?
No, it wouldn't, because that mean is so far out past 75% of the data. The mean and the standard deviation as descriptors of data do not take into account the skewness of this data.
Based on your review, did Dr. Horn accurately reflect the natural variability of TSS for this project? Can you please explain why not?
Two reasons, both because total suspended solids was described in the baseline data as historic data and by Enbridge's data taken at multiple sites across the watershed and not for any one site in particular. And because the mean and the standard deviation were used to describe that variability, it highly inflates the sense of variability.
Thank you. At this time, environmental petitioners would move Exhibit 118 in its entirety into the record.
No objection.
No objection.
No objection.
118 is received.
Ms. Ledder, are you aware of any water quality standards in Wisconsin that would be applicable to total suspended solids?
Yes.
What are those water quality standards?
The total suspended solids standard is more of a narrative standard. That means that there's not one single number that needs to be met. Dissolved oxygen has several numeric standards related to the type of water body and its use as fish habitat and particular needs. Suspended solids is really a reflection of the geology of an area, what type of soil is in that stream bed, a number of other factors that are really particular to the type of water body and the location of that water body. So statewide, it's impossible to state one numeric criteria that all water bodies would need to meet. Therefore, it's a narrative criteria, which basically encompasses no negative impacts, no negative impact to aquatic life, and no negative impact to the public's use of that water body.
Does Dr. Horn opine on project-related impacts to TSS in his pre-filed direct testimony?
Yes, he does.
What is your understanding of that opinion?
That any impact to considering the parameter of TSS would be local and temporary.
Did Dr. Horn discuss TSS impacts resulting from dry trenching construction methods in his direct testimony?
Yes, he did.
We're going to turn now to page 38 of Dr. Horn's testimony. Can you please read aloud from line 9 through line 14.
Pipeline installations in small water courses are anticipated to be completed within approximately 20 hours and would only actively release sediment for a maximum of 4 hours. These activities were determined to introduce initial TSS concentrations up to 132 milligrams per liter above background. However, as these impacts travel downstream, sediment concentrations decrease precipitously, with TSS levels predicted to return to typical background concentrations by 1,000 meters downstream.
And can you also read lines 19 through 22 on the bottom of page 38 and lines 1 through 2 on page 39?
Crossings of medium-sized watercourses are anticipated to be completed within approximately 32 hours and would actively release sediment for a maximum of 10 hours. As with dry trenching activities in small watercourses, initial TSS concentrations at the point of disturbance were maximally determined to be 132 milligrams per liter above background. Similarly, these concentrations were modeled to return to typical background concentrations by 500 meters downstream.
In your opinion, could an introduction of TSS up to 132 milligrams per liter above background be acutely harmful to animal, plant, or aquatic life?
It could be for those animals living there at that time.
And can you please elaborate on that opinion?
Suspended solids, as introduced into a stream at a construction site, will travel downstream depending on the site characteristics of flow, stream width. Water flow has power, and it can carry suspended solids at different distances depending on the stream itself. In the immediate vicinity, and as the model predicted as the extreme end of 500 meters downstream, habitat for small aquatic organisms can be covered by that suspended solid.
So does Dr. Horn's assessment that TSS would resume to typical concentrations 500 to 1,000 meters downstream change that opinion?
No, it would not, and keep in mind that 1,000 meters is approximately 0.6 of a mile.
2 final questions. Can you please, actually we're going to display just Exhibit 376 one final time. On page 12, can you please read aloud the last 2 sentences, beginning on line 11 and ending on line 15?
The ranges of natural variability for each parameter analyzed were orders of magnitude larger than any anticipated project-related impacts. Therefore, the project's anticipated water quality impacts are expected to be exceedingly minimal in the context of natural variability, to the point they would be difficult or even impossible to identify and/or measure.
Do you agree with that conclusion?
No, I do not.
Why not?
Again, the variability as presented in the expert report and the monitoring plans and the monitoring reports is basin watershed-wide variability, which is not relevant to any one particular stream that is being crossed and potentially impacted by the project. You would need more baseline data at each of those sites to determine the natural variability at that site in order to determine whether there is a significant difference or not between your upstream and your downstream sampling as that construction proceeds.
Thank you. No further questions at this time.
These wasn't just the main questions.
No questions from the board.
Chair, we will have some questions for this witness. I'll request that we take a 5-minute break before we proceed.
It's just before 10:15. We will take a break until 10:40. Thank you.
Thank you, Your Honor. Ms. Ledder, my name is Michael Kalkowski. I'm an attorney with the Department of Natural Resources. There's just a few areas of your testimony I'd like to explore with you today. I want to start with water quality. Now, in your pre-filed testimony, you cite the process for designating impaired water bodies under the Clean Water Act as an example of multiple years of monitoring, correct?
Yes, I do.
And this is known as the whisk column method, correct?
Yes.
Now, this is a significantly different context than we're discussing on a project level today, is it not?
Yes.
This method is used by DNR, by the department, to determine if a water body is attaining or not attaining water quality standards, correct?
Yes.
And whether to list a water body on the impaired list, the list of impaired waters, correct?
Yes.
Designating a water body as impaired has significant regulatory consequences for any point source potentially discharging to a water body, correct?
Yes.
Are you aware of the whisk column method being imposed on any single regulated project in Wisconsin?
No.
In fact, the whisk column guidance itself, which is found included in your exhibit 118C, makes no mention of its application to regulated projects at all, correct?
Correct.
Ms. Ledder, please pull the microphone closer so you can pick up your answers. Thank you.
And are you familiar with the Wisconsin Pollution Discharge Elimination System?
Yes.
WPDS is the acronym. Are you comfortable with that acronym?
Yes.
So the WPDS program has been established by the state of Wisconsin in compliance with the Clean Water Act, correct?
Yes.
And that permit process applies to industries discharging chemicals in their effluent directly to surface waters, correct?
Yes.
And these dischargers of pollutants are not required to perform baseline water quality monitoring of the receiving water, isn't that correct?
Not all the time.
Can you cite an example of a WPDS permit for the discharge of a pollutant from a point source where such baseline monitoring of the receiving water has been required?
My experience is in the state of New York, where I personally have worked with several municipalities in which the background of any particular parameter for which their limits are going to be set is in question, and they have had to sample the receiving water upstream and downstream prior to setting those limits.
And so the answer to my actual question is no, you can't point to an example in Wisconsin.
Not in Wisconsin. It's not in my experience.
And are you aware that the U.S. Environmental Protection Agency oversees and audits Wisconsin's discharge program under the Clean Water Act?
Yes.
Are you aware of any EPA action that indicates that Wisconsin should include such baseline monitoring to be in compliance with the Clean Water Act?
Not sure I understand the question.
You understand EPA's role to be oversight and audit of the program, correct? And in doing so, they're assuring compliance of that program with the Clean Water Act, correct? And are you
Yes, yes, yes.
are you aware of any suggestion from EPA to the state of Wisconsin that baseline monitoring of the stream should be included in its program to be in compliance with the Clean Water Act?
Not in my personal knowledge.
Now, in your pre-filed testimony, you state that Enbridge uses an inaccurate method to convert TSS sample results to, you're going to have to help me with the pronunciation here, but NTUs. Could you tell us what NTUs are?
Nephelometric turbidity units.
And are you comfortable if we just use NTUs?
Yes.
Okay. Now, the Bad River Band has a turbidity water quality standard expressed in NTUs, correct?
Yes.
But the state of Wisconsin does not have a water quality standard for turbidity expressed in NTUs, correct?
Yes.
In fact, the state of Wisconsin has a water quality standard for TSS, but not for turbidity.
Yes.
And that standard is a narrative standard, as you testified to, and not a numeric standard, correct?
Yes.
So whether or not Enbridge accurately converted to NTU has no bearing on Wisconsin's standard, does it?
No.
You stated that the water quality monitoring plan does not describe adverse change, correct?
Yes.
And by that, do you mean in numeric terms?
Yes, because the data is being taken in numeric concentration readings, and therefore the significant difference is comparing upstream and downstream.
And if that numeric difference upstream and downstream is used as an action limit, would that not convert Wisconsin's narrative standard to a numeric one?
Yes, because you're defining impact, which is a narrative.
Just to come back around to that, make sure I'm understanding your response. Wisconsin's standard is a narrative standard expressed in narrative terms that allow for evaluation of the impact of a particular pollutant on the environment, correct?
Yes.
Okay. And in no way are those expressed in numeric terms in those standards.
They're not.
I want to turn a little bit to some testimony you provided regarding wetland monitoring, wetland hydrology monitoring. I noticed in your testimony you stated that you have experience conducting wetland delineations, correct?
Yes.
But you were not asked to review any delineations or wetland identification information for this project, correct? Now, in your expert report and in your testimony, I want to talk about monitoring wells. You state that a 15-inch monitoring well is too shallow, correct?
Yes.
Are 15-inch monitoring wells commonly used to monitor wetland hydrology?
Wetland hydrology is not commonly monitored.
And when it is, 15-inch wells are regularly used, correct?
Not according to the guidance. That's a standard. It doesn't give any determination of how often 15 is used.
Would it be accurate to say there are essentially two types of wells that are used for this purpose, 15-inch wells and 24-inch wells?
No, I would say there's several other wells out there that are different distances depending on conditions.
Okay, now 15-inch wells, let me ask about your experience with regard to wetland restoration sites. Have you been involved in performing wetland restorations?
No.
Have you been involved in monitoring hydrology with respect to wetland restorations?
No.
As it relates to a 15-inch monitoring well, that's going to show us water level fluctuations in the relative near surface area, correct?
Yes.
And that area is important because that is the upper rooting zone of aquatic vegetation within a wetland, correct?
Yes.
And you go on in your testimony to talk about times where a 15-inch monitoring well might not register any reading, correct?
Yes.
And that's because of natural fluctuations, or could be because of natural fluctuations that are occurring in that ecosystem, correct?
Yes.
With any monitoring that you would do of a monitoring well, would you ever look at a single reading in isolation?
Depending upon the objective, and in this case, the objective is looking at the regime of water fluctuation and comparing upstream, downstream, and impact area.
And so here we're talking about wetland monitoring.
Yes.
So in terms of the existence of hydrology in the wetland and any potential changes to that hydrology, wouldn't one want to look at a series of data to understand whether there were consequences that have arisen from any particular impact, or would one look simply at a reading in isolation?
It's my understanding that the intent is to look at up gradient, and I used the term upstream, I use those interchangeably. One reference well, and then downstream monitoring well, and there's a monitoring well going to be placed, according to the plan, within the construction zone. So all of those regimes of long-term fluctuation.
Sure. And those are taking readings every hour, correct?
I believe so.
And when I reference one reading, and maybe I should be clear, I'm talking about the readings associated with the paired wells. So would you take, if you wanted to understand impacts to hydrology or potential changes to hydrology that have occurred, would you take one of those paired readings in a snapshot, or would you want to understand the sequence of paired readings leading up to and following that reading?
You would want the seasonal sequence.
Now, with those monitoring wells, there may be times in the year where the upgradient well is recording water and the downgradient is not, correct?
Or vice versa, correct?
And while not a confirmation, because we don't have a reading from a 15-inch well, that there's a hydrologic issue occurring, this information could be useful in combination with those other pre and post readings to understand if impacts to hydrology are occurring, correct?
I don't believe so. If you don't get any data because your well is too shallow, it's very difficult to infer.
Now, water in one well versus water in another tells us that we have a difference up gradient and down gradient, does it not?
Not necessarily. Could be a half an inch lower, which is not, may or may not be significant depending on the long-term seasonal data.
Exactly. And so one would want to compare that result that you're getting with the results from other times of the year immediately preceding where there is water in the two wells, correct?
In my opinion, I'd prefer to have a deeper well to have a more complete record.
But you wouldn't look at that single reading of the paired wells in isolation, as I believe you testified it would be important to look at the series of readings to try to understand what's happening,
Yes.
correct? And in any event, monitoring wells are not the only way to identify potential hydrologic impacts to wetlands, correct?
Correct.
You stated that they're not commonly used.
The objective of the guidance utilized was to identify a wetland, not to look at monitoring. It specifically states in that guidance that it's not to be used for monitoring.
I don't think that's the question I asked you. I believe the question I asked you was in your testimony. You stated that wetland, these shallow monitoring wells are actually not commonly used.
Not commonly used for monitoring.
Correct. Thank you for clarifying the scope of that testimony. So the other ways to identify potential hydrologic impacts to wetlands would include observations of the vegetation of the wetland, correct?
For hydrology, there's not, vegetation is not the main one to use for hydrology.
Not the main one to use for hydrology, but the impacts, any potential changes in hydrology are reflected in the vegetation, are they not?
Yes.
And so looking at vegetation gives us some information about potential changes to hydrology, correct?
In the long term.
And the presence and extent of wetland boundaries would also be a way to understand how hydrology is or is not affected in the area.
Yes, and again, that would be in the very long term.
Because wetlands naturally fluctuate
Yes.
their boundaries. Now I want to turn and talk a bit about erosion control, which I think is pretty central to this particular project. In your pre-filed testimony, you state that Enbridge's construction and erosion control plans do not explain how to install BMP's best management practices. Are you familiar with that statement from your testimony?
I do not recall that particular statement.
I'll direct you to Exhibit 128, which I understand to be your pre-filed testimony on page 40. I'll have you review.
This statement in general? Where? Read this line that's up on the screen.
Could you please highlight? Give me just one moment if you would, please. Could you review the highlighted statement?
And the question was?
Your statement in testimony here is there's no explanation of how maintenance and inspections will be carried out.
Yes.
Did you stand by that statement today?
Yes.
I'd like to turn your attention to what's going to be displayed on your screen as Exhibit 786, please. Did you review this document?
Not in any detail, no.
And this is the Line 5 erosion and sediment control plan, correct?
Yes.
which would be a critical document to review to be able to make the statement that you put on the record?
I was not asked to review the particular claims.
If you were to make statements about erosion control and sediment as it relates to the Line 5 project, would you, as a scientist, want to review the erosion and sediment control plan?
I reviewed documents related to erosion and sediment control in a general way, yes.
But not the erosion and sediment control plan.
It is not my testimony that it would not be set up or installed correctly. My point is to lack of information on management and inspection, which is important to any erosion control.
So wouldn't you want to understand if there's a document which actually contains the answer to your question?
Any construction details is usually the general utilized document that shows where and how things are installed. I saw nothing on management and inspection.
Okay. And just to be clear, you're stating that you haven't reviewed the Line 5 erosion and sediment control plan that's been marked as Exhibit 786.
Not in detail.
I think that can address a number of, actually, I'm going to stay there for a moment. Not in detail. Can you describe what you mean by that?
Specifically because of the characteristics of the red clay plain in northern Wisconsin, it's susceptible to erosion. I've seen, in my experience, in monitoring across the watershed, there are long-term impacts from rutting and other erosion caused by just land use. So it's my concern in my testimony that the management of sedimentation and erosion controls, once they're placed, is extremely important, especially after a high rain event. Inspection needs to happen. There needs to be staff and personnel on site and ready to inspect that and remedy or fix any storm-related impacts to the control structures themselves.
I'm going to move to strike that answer as completely non-responsive to the question I asked you, which is, you testified that you did not review the Line 5 erosion and sediment control plan in detail, correct?
Correct.
And I asked you, what do you mean by reviewing in detail? How did you review this document?
I've read through it in a general way and not looking at any site-specific plans.
In a general way, you skimmed this document?
Yes, pretty much. These are very generic construction guidelines.
Now, I want to turn, I think that answers a lot of the next series of questions I have for you, which were based on this document. One final question. If I'm looking at specifics of this document, the chances are that that's not coming into your recollection in your skimming of this document, correct?
I probably not.
Now, in your expert report, I believe it's carried over in your testimony, you talk about the concept of environmental monitors, correct? Independent environmental monitors. Can you describe for us what you understand an independent environmental monitor to be?
Independent environmental monitors will be basically contracted by the state of Wisconsin. They will be out on site. They don't have stop work authority. They're both basically helping the inspectors from Enbridge on site interpret some of the requirements for the general stormwater permit. I have no idea how many of those there are and how that relates to actual active construction sites.
Okay. And are you aware of how much of the construction corridor would be actively worked at any given time?
I did not see any detail of that, and I don't believe that's known until you get actual weather conditions and site conditions upon construction.
Known with certainty.
Yeah.
But it can be safely assumed that the entire 41 miles of the pipeline is not going to be actively worked at one time.
I understood that, yes.
Are you aware of any regulated project in Wisconsin which has required more independent environmental monitors?
No.
Are you aware of any that have even required 3?
No.
And there are certainly projects in Wisconsin which exhibit longer project corridors, correct?
I do not know of any.
You're not familiar with any of the transmission projects that have occurred in the state of Wisconsin?
I do not know the details on the length or construction at those sites, on those
It's,
projects.
you do not know the details. So you are not aware of any projects in Wisconsin that are longer than 41 miles of a construction corridor?
No.
Okay. I don't have further questions for you. Thank you.
Questions from the section?
Yes.
Ms. Ledder, my name is Nick Kovac. I'm an attorney with Foley and Lardner, and we represent the permittee Enbridge Energy Limited Partnership. Just as an initial matter, as you'll see, Ms. Hughery and Attorney Mawson are handing out binders, physical binders with excerpted copies of some of the exhibits that I may reference throughout this examination. As we've done with other witnesses in this case, we'll also be putting up electronic versions of these documents for your review. So to the extent you want to use the physical binder, feel free. To the extent you prefer to just look at the virtual image, that also works. Now, Ms. Ledder, as established this morning, one focus of your testimony is the project's water quality monitoring plans, correct? And throughout your testimony, you refer to the WQMP, and that is the water quality monitoring plan, correct?
Yes.
And that is attached as Appendix T to the final EIS,
I believe it was.
and it's marked as Exhibit 829 in this proceeding, right? And this document has been through multiple different versions throughout the permitting process, correct?
Yes.
And in your testimony, you state that you reviewed these various versions, right?
Yes.
Now, within that binder in front of you, you'll find a copy of Exhibit 829. Again, we'll be referring to this throughout my questioning today. But I do want to note that is not the entire document. As you're well aware, the full document's over 800 pages long. But because this binder only includes the certain relevant excerpts, and because it is, a document that is referenced throughout your testimony, I'd like to just quickly go through what's in Exhibit 829, just to make sure that we're on the same page. Is that okay?
Yes.
So of course, there's the WQMP, is one of the documents in Exhibit 829, and that establishes the project's water quality sampling plans, correct?
Right.
And it includes plans for water bodies as well as wetlands, right?
Yes.
And broadly speaking, the WQMP sets forth information like what water quality samples are to be taken, right?
Yes.
When they're going to be taken,
Yes.
the location where they're going to be taken,
Yes.
as well as what water quality parameters will be analyzed, correct?
Yes.
It also sets forth certain reporting requirements that Enbridge has to adhere to. Is that right?
Yes.
And attached to the WQMP are a few different attachments or appendices, correct?
Yes.
And one of those is an attachment 1, and that includes over 100 pages of different maps that indicate the sampling locations, right?
Yes.
And then there's also information regarding the locations of the groundwater monitoring wells that you just discussed with council, correct?
Yes.
There's also some charts and some tables that show the frequency of testing of the various water quality parameters, as well as listed in those tables are the applicable chemical testing methods, right?
Yes.
Now, as you discussed this morning, one of the attachments to the WQMP is the Surface Water Sampling Quality Assurance Project Plan, or QAPP, correct?
Yes.
And you discussed kind of the general purpose of the QAPP this morning, so please correct me if this is incorrect, but essentially QAPPs include details regarding quality assurance and quality control measures for project activities that relate to data. Is that correct?
Yes.
And now, for this project, the QAPP itself actually has a few appendices, right?
I'm not remembering which ones they are.
So if we go to Appendix B, which is page 188, we can see, here's just one example. These are operating manuals for various sampling devices and pieces of equipment.
I understand what you mean.
Yes. And essentially, this specific appendix just goes through, how to use the various pieces of equipment, how to maintain them, and how to calibrate the equipment, correct?
In general, yes.
Now, another appendix to the QAPP, and this is Appendix C, it starts at page 424. So this is labeled the Analytical Laboratory Quality Assurance Plan, and it includes the standard operating procedures for the laboratory that was retained by Enbridge for this project, correct?
Yes.
And as you're aware that the laboratory that Enbridge is contracted with is PACE Analytical Environmental Sciences, is that correct?
Yes.
And you don't dispute in your report or your testimony that PACE is a reputable lab.
I raised no discussion on the base at all.
Now, Appendix C, this appendix, also includes the standard operating procedures for the various water quality parameters to be analyzed by PACE throughout the project. So any water quality sample that's collected that needs to be analyzed in a lab, this document walks through the standard operating procedures for PACE to analyze them.
This is quality assurance for the laboratory activity, yes.
Now, the QAPP also includes about a half dozen additional appendices that establish things like guidelines and procedures for collecting water samples and visually assessing streams, correct?
Correct.
Now, you're familiar with this project's water quality certification, is that correct?
Yes.
And that's marked as Exhibit 633 in this proceeding?
I'm sorry, I'm not up on all the numbers. Yes.
And issuance of water quality certifications, that's governed by NR Chapter 299, correct?
Yes.
And specifically, NR Section 299.04 requires DNR to determine it has, quote, reasonable assurance that the proposed activity will comply with certain applicable state water quality standards, correct?
Yes.
And now these standards they're primarily set forth in NR Chapters 102 and 103, is that right?
Yes.
And NR Chapter 102 covers Wisconsin surface waters, right?
Yes.
And by surface waters we mean streams, lakes, and rivers mostly, right?
Yes.
Whereas NR Chapter 103 sets forth different standards for Wisconsin wetlands. Is that correct?
Yes.
Now, as you noted this morning in your testimony, some of these standards are quantitative or numeric, correct?
Yes.
And the example you gave was dissolved oxygen in surface waters, right?
That's one of them. Yes.
That's one of them. And that's governed by NR 102.04 subsection 4A, and as you testified, it sets forth that certain water bodies must attain certain minimum dissolved oxygen concentrations, right?
According to the water quality standards.
So overall, when it comes to these quantitative or numeric water quality standards, like for dissolved oxygen, it's fairly easy to take a sample, compare it to the standard, and figure out whether there's a violation or not, correct?
whether or not there's a violation of the standard, but not necessarily whether there's a significant impact, as is written in the water quality monitoring plan.
Yeah, I'm referring specifically just to the state standard, correct? You just take the measurement, you compare it to the standard, for dissolved oxygen, if the measurement's below the state standard, there'd be a violation, correct?
Violation of the standard.
Of the state standard, yes. Now, on the other hand, as you noted, there's some parameters that don't have numeric thresholds in the state standards, correct?
Correct.
And one of those is sediment, as you noted, correct?
Yes.
And you walked through this morning some of the narrative provisions of these sediment standards. Again, there's no numerical thresholds, but instead violations are determined by considerations like whether substances cause objectionable deposits, correct?
Yes.
Or cause floating or submerged debris,
Yes.
or produce color, odor, taste, or unsightliness to such an extent that they interfere with public rights in the waters of the state.
Yes, there's also the requirement to not have a negative impact on aquatic life in general for all of these water quality standards.
Correct, and that's whether substances are toxic or harmful to animal, plant, or aquatic life. Correct.
Yes.
Now, and you may have answered this morning, but it's possible that the release of a certain volume of sediment to one water course could be a violation of the state standard, whereas the release of that same quantity to a different water course with different characteristics might not be a violation of the state standards, correct?
It depends upon the impact of that particular stream, yes.
So it's stream specific, correct?
Yes.
And it depends on things like the flow rate of the stream, right?
Yes.
The channel width, the width of the stream, correct? The depth of the stream,
Yes.
potentially substrate conditions, what's on the bottom of the stream,
Yes.
and then things like season and weather can also have an impact, correct?
Yes.
So I just want to confirm, it's not your testimony today, as counsel previously asked you, that Enbridge or DNR has to try to approximate numerical equivalents for these qualitative standards, correct?
It's my testimony that as written in the water quality monitoring plan, the determination is a significant difference between upstream and downstream during construction or pre-construction and post-construction.
Now I'm referring simply to the state standards. In order for Enbridge or DNR to quantify or determine whether they've violated a state standard for sediment, you're not taking the position that they have to approximate these numerical values.
That's not as is written in the water quality monitoring plan, and it's my statement that if there is an impact between upstream and downstream or pre-construction and post-construction, impact to that water body might be, as you just were discussing, for that water body might be a violation of the water quality standard.
But to confirm, something that you mentioned this morning is that I believe you said it's impossible to have a single statewide quantitative threshold for sediment, correct?
Correct.
Now, as I understand your testimony, your position is that Enbridge's water quality monitoring plans, and specifically the WQMP and the attachments thereto, are deficient. Is that correct?
Yes.
In fact, so deficient that DNR could not have had the, quote, reasonable assurance that it needs under NR 299-04 to issue the water quality certification. Is that correct?
Yes.
And that specifically these deficiencies prevent Enbridge or DNR from being able to identify whether the state water quality standards have been violated by the project.
According to the water quality monitoring plan, it's the term significant difference. And I believe the determination of significant difference is what is being described here in the water quality monitoring plan. Those determinations of significant difference or significant impact at any one site would be what the DNR would utilize to determine water quality standards
Okay, so you're
violations.
Sorry.
There's some translation going on there, yes.
So, would it be accurate to say that your testimony is focused on the term significant difference as that appears in the water quality monitoring plan, correct?
Correct. That appears in the water quality monitoring plan to be a main basis of determination of impact.
Now, I also want to clarify that nowhere, either in your report or your testimony, do you identify any specific water quality standards that will be violated by the project. Is that correct?
Correct.
You don't cite any specific standards in either NR Chapter 102 or 103. Is that correct?
Correct.
Now, one of your criticisms of the project, as we heard this morning, is a lack of adequate baseline water quality data. That's correct?
Yes.
And that includes data that has already been collected and analyzed by Enbridge and DNR, correct?
Yes.
As well as additional data that will be gathered by Enbridge as the construction progresses.
I can't speculate on the results of the data that will be collected, but it's my testimony that the water quality monitoring plan as it stands will not allow determination of impact.
And that includes the portions of the plan, the water quality monitoring plan, that are prospective, samples that have not been taken yet.
That will happen in the future, correct?
Now, I'd like to clarify that when you use the term baseline data, you're referring to data that can help establish a water body's pre-construction conditions. Is that accurate to say?
Yes.
Essentially, the natural condition of a water before construction begins.
In its existing state before construction begins, yes.
And the reason for that is that once construction begins, subsequent data can be compared to this baseline, correct?
Yes.
And in theory, comparing the post-construction data to the baseline data would allow one to evaluate the project's impacts.
Yes.
Now, you note in your testimony that baseline water quality data is usually collected over several years, correct?
Yes.
And you previously discussed with council, you referenced WISCOM, which is the Wisconsin Consolidated Assessment and Listing Methodology, correct?
As one example of long-term data, yes.
Correct. You acknowledge that WISCOM does not have any relevance to the permitting done here, correct?
No, I used it as an example of seasonal multiple year requirements to make a decision about water quality.
Now, to your knowledge, there is no specific, such as a 5-year sampling requirement set forth in the Wisconsin statutes that apply either to the water quality certification or to the WQMP. Is that correct?
Correct.
And there's no such specific sampling requirements set forth in DNR regulations either.
I don't know.
And in fact, neither the state statutes nor the regulations require any set amount of pre-construction water quality sampling.
No.
Now, I just want to confirm, is it your position that for any construction project in the state of Wisconsin, the permittee must first conduct site-specific water quality monitoring for 5 full years?
It's my testimony that the water quality monitoring plan, as included in the certification, does not include sufficient definition of what a baseline is to determine impact. So whether or not there's any statewide criteria for baseline is not the point. It's my concern that large projects that cannot determine whether or not they've actually made an impact in future construction yet to happen is not able to identify an impact or exceedance of water quality standards.
So is your testimony is for this project, what has been done to date is not sufficient, correct?
Correct.
And are you prepared today to testify that, I'm going to re-ask the question I previously asked. The permittee for any construction project has to first conduct site-specific water quality monitoring for a set amount of years.
Not a set amount of years, as much as sufficient to have determined some natural variability pre-project according to seasons, changes in seasons and across different years. I'm not saying specific number of years, I'm saying sufficient data.
Just more.
Yes.
Now, because your position is that here, the water quality data that was collected by Enbridge and submitted to DNR is deficient, I want to quickly spend a minute to discuss the data that Enbridge has collected, and then as well as the data prospectively that they will collect. Okay?
Yes.
Now, the WQMP requires Enbridge to conduct water quality monitoring for the project, and that begins with water quality samples before construction begins, correct?
Yes.
And then additional samples during active construction,
Yes.
and then post-construction sampling.
Yes.
Now, as you noted in your testimony this morning, Enbridge has already collected some of the water quality samples required by the WQMP, correct?
Yes.
And this process began in 2023, right?
Yes.
And in accordance with the WQMP, Enbridge visited each water body crossing, right?
Yes.
And there's over 200 of them, correct?
Yes.
And at each of these sites that had sufficient water at the time, Enbridge collected 2 separate samples, correct?
Yes.
And that would be one sample 100 feet upstream of the crossing, right?
Yes.
And then the other one 100 feet downstream.
That was the intent, yes.
And during this 2023 sampling, Enbridge also took photographs of the sampling locations, correct?
Yes.
And they recorded these locations using GPS, correct?
Yes.
And the purpose of that was to document the exact locations where they took these samples for future use.
Yes.
And you understand that the subsequent monitoring events will take place at these same locations.
As construction conditions allow, yes. That's the
Yes,
intent.
and it is specified in the WQMP.
Yeah.
Then in 2023, when Enbridge collected these samples, they then sent, at least the samples that needed laboratory analysis, they sent them to PACE labs, correct?
Correct.
And PACE then analyzed each sample for a variety of parameters. Is that correct?
As requested, yes.
And that includes a list of chemical parameters, right?
Yes.
And then there were biological parameters and physical parameters also analyzed, correct?
I'm not aware of anything other than fecal coliform analyzed for biology.
By PACE, correct?
Yes.
There were other in-field
Yes.
analysis, correct? Now I'd like to introduce Exhibit 829, page 8. And specifically Table 1. If you let me know when you get there.
I'm going to try to use the document so I don't have to change glasses.
Okay, that works. You there? Now you can see here, this is a table that describes the various parameters to be analyzed during the 2023 sampling initiative, correct?
Table 1 is labeled pre and post construction.
Yes. And that applies to 2023.
Yes.
And it includes chemical parameters like total phosphorus, right?
Yes.
Ammonia, dissolved oxygen. There's a whole host of parameters there, correct?
There's some standard fields parameters and some standard other parameters, yes.
And by other parameters, you mean laboratory.
Laboratory analytical, yes.
Now there's also, if you look at the middle column and the right column, there's over a dozen other physical and biological parameters listed there too, correct?
Physical parameters, biological parameters in terms of observations in the field.
Okay. And that includes things like temperature, right?
Yes.
Turbidity,
Yes.
stream characteristics, and then the presence of aquatic organisms.
Yes.
So to confirm, in 2023, Enbridge collected these site-specific samples from the various water body crossings and it analyzed each for these, around 30 kilometers, correct?
Yes.
In 2023, Enbridge collected these site-specific samples from the water body crossings and analyzed each for the 30 parameters listed. That's correct?
Correct.
Thank you. And then, as required in the WQMP, Enbridge visited these same locations in 2024. Is that correct?
Correct.
And they did all this all over again.
Yep.
So overall, between 2023 and 2024, Enbridge collected several hundred site-specific water quality samples, correct?
Yes.
And then they analyzed each one for the 30 parameters that are listed in Table 1.
Yes.
And then Enbridge submitted these data, as you noted this morning, and the results to DNR in 2 separate reports. Is that correct?
Yes.
And one of them is the 2023 water quality report,
Yes.
and that is attached as Appendix U to the final EIS. Is that right?
Yes.
And it's around 300 pages. Is that?
Yes.
And then they also finalized the 2024 report, correct?
Yes.
And that is over 3,000 pages, correct?
If you include all of the laboratory data, yes.
Okay. And all the data that was collected is included in that.
Right.
And DNR received this report and reviewed that.
Yes.
Now, I want to quickly clarify a somewhat minor point, but throughout your testimony and this morning, you characterized the data collected by Enbridge in 2023 and 2024 as 2 data points. Is that correct?
For each particular site, you've got 1 data point at each of those locations for each report.
Correct, but
So that's 2 total for each individual sampled site.
correct, but I want to clarify that when you're referring to each site, are you referring to each water body crossing?
In terms of the way the water quality monitoring plan is written, each sample taken at the upstream site is 1 sample. I grant that for each water body, you're taking an upstream and a downstream, which you could term to be 4.
Okay.
But they're taken at the same time, so it's 2 descriptors.
Okay, that's just what I wanted to
Clarify, yes.
Thank you. Now, in addition to the 2023 and the 2024 water quality samples that were already taken by Enbridge and submitted to DNR, the WQMP also requires Enbridge collect additional samples prior to construction. Is that correct?
Yes.
And that would be specifically 5 days before construction begins. Enbridge has to take, again, upstream and downstream water quality samples.
Yes.
Correct? And those are the same exact locations as reported by GPS in 2023.
Yes.
Now, the WQMP, as you noted, also requires active construction sampling, correct?
Yes.
Again, same locations as the previous samples, correct?
Yes.
Upstream and downstream.
Yes.
And as you're aware, the WQMP lays out separate protocols for different crossing methods. Is that correct?
In terms of where the site location is, yes.
Yeah, I'm referring to certain sampling requirements for dry trenching as opposed to HDD.
Okay, yes.
There's separate plans in place, correct?
Yes.
Now, I'd like to take a look just at the active construction sampling requirements for dry trenching. So if you could turn to page 9 of Exhibit 829. And you can see it begins with section 2.2 active construction sampling, correct?
Yes.
Okay, now if we flip to page 10, you'll see in the bullet points listed towards the top of the page, the WQMP requires upstream and downstream samples prior to the start of construction, correct?
Yes.
And then there's also samples to be taken during dam installation, right?
Yes.
And if a stream is under 10 feet wide, that's 1 sample upstream, 1 sample downstream, correct?
Yes.
And then if it's over 10 feet wide, it's 2 at each location.
Yes.
Correct. And then the WQMP also requires upstream and downstream samples throughout active construction. Is that correct?
Yes.
And that's every 2 hours?
Every 2 hours as long as there's a visible impact once the dam is reviewed, or dam is placed and before it's removed. Is that what you're describing?
Correct, yes.
Okay.
Every 2 hours while isolation dams are removed.
Right. Sorry.
And the WQMP notes that these crossings using the dry construction technique can take anywhere from 24 to 48 hours, correct?
Yes.
So that's an additional 12 to 24 samples during active construction.
Yes.
And then actually twice as many because it's one upstream, one downstream.
Yes.
And then there's also additional sampling during dam removal, correct?
Yes.
And it's largely the same as the dam installation where for streams under 10 feet wide, it's one upstream, one downstream, over 10 feet wide, two at each location, correct?
Correct. And can I just clarify that you are talking about table 2, or is there a different table?
I'm speaking about on page 10, there are some bullet points at the top of the page. Do you see where that is?
Okay, so we're only talking about field turbidity readings during construction and the dam installation time period. You're not talking about table 2 or any of the other tables. I'm just talking about the turbidity sampling to be
I'm talking
taken.
about the sampling that's indicated in the model, correct?
Yes, turbidity during actual dry trench.
Now, the WQMP also establishes sampling for what's deemed, or what's called near-term post-construction, is that correct?
Yes.
And that includes daily upstream and downstream samples for a period of 3 days.
Yes, and one of those tables is specific to post-construction, correct? So we're not talking about the total list of 30 parameters during dry trenching, and is post-construction the total, please refresh my memory, I'm a little, I need to look at this, but post-construction near term, is that the complete table of 30 parameters, or is that another abbreviated table?
Well, it's all set forth in the WQMP.
Right, can you show me where that is if we need to discuss it, because I want to make sure I'm remembering correctly. Yes, so table 1 says water quality parameters to be sampled pre and post construction. Table 1 is the complete list of what we discussed earlier, is 30. And does that include the near term? Near term post construction also includes this table 1, is what I'm trying to clarify. I'm not sure I'm remembering correctly.
Well, I'm not,
Do you want to take a moment and review the
Yeah.
exhibit?
sure.
It's section 2.3.
Yes, yes.
So that says table 2 parameters, which is the shorter table. So that short term, near term post construction is 1, 2, 3, 4 parameters and 2 observations.
That's correct.
Okay.
Now, you acknowledge in your testimony that each pair of downstream and upstream samples are going to be collected at roughly the same time. Is that
Yeah.
correct? Under the same weather conditions, correct?
Yes.
Same ambient air temperature, and under roughly the same flow conditions of the stream. Is that correct?
Correct.
Now, and because one sampling location is upstream of the construction, and then the other one's downstream of the construction, that means that all construction-related activities in the stream are between those 2 points. Correct?
Mhm.
So the only real difference between each pair of upstream and downstream samples is just the impact of the construction.
During construction. Yeah.
And again, the upstream sample, that represents the natural condition of the stream unaffected by the project, correct?
Yes.
Whereas downstream, during active construction, would indicate the condition of the stream as affected by the project.
Yes.
And in your own words, the WQMP states in numerous places that the downstream results will be compared to the upstream results, correct?
Correct.
And by doing this, project-related impacts are largely isolated, right?
To a site specific.
Yes.
Yes.
And therefore it becomes easier to distinguish what impacts the project is having on the water quality parameters analyzed. Is that correct?
On a site specific basis would be the determination of impact.
So at each site, if you were to compare the downstream to the upstream sample, you could get a clear sense of what the project, how the project is impacting the water quality.
If there was any criteria for determining difference for each parameter, which each parameter has differing variability, different ranges at each specific site, and the water quality monitoring plan has no definition of what difference in numbers for each parameter is to be considered significant difference.
But generally, this methodology of comparing a downstream sample to an upstream sample here, that would, you'd be able to see how the stream is impacted by the construction.
The sampling methodology is correct.
And in your own words in your testimony, the ultimate question here is, was the stream impacted by the construction?
Yes.
Now, in your direct testimony, you were asked whether it is appropriate to avoid sampling during high flow events. Is that correct?
Yes.
And one example of such a high flow event could be during or after a large rainstorm. Is that
Yes.
correct?
Mm-hmm.
And you responded in your testimony that it's not necessarily appropriate to avoid sampling during high flow events.
Yes.
And you acknowledge that part of the reason that Enbridge is not proposing to conduct sampling during these times is because of worker safety.
Yes.
Certain high flow events can lead to pretty dangerous conditions when you're working on the water, right?
Again, it depends on the size of the water body.
But it happens.
It can be, yes.
And you're aware that the WQMP establishes that Enbridge is not going to conduct any water body crossings during high flow events, right?
Correct.
And as a result, all water quality sampling that's going to be conducted immediately before, and then during and after construction will be collected during normal stream flow.
That's the intent, yes.
And as you've testified this morning, changes in stream flow can have a drastic impact on different water quality parameters, correct?
Yes.
For example, you pointed to TSS and noted that some of those higher values are attributable most likely to large rainstorms.
Yes.
Correct? Now, throughout your testimony, when you refer to baseline data, you seem to be squarely focused on the data collected by Enbridge in 2023 and 2024. Is that correct?
Yes.
Now, do you acknowledge that each upstream sample that Enbridge proposes to collect necessarily acts as a baseline reference point to its downstream sample?
It expands the database as construction continues.
Yes, but in terms of baseline data as we defined it earlier, baseline data is there to establish a stream's natural conditions.
Yes.
And that's what these upstream samples do.
Upstream is a reflection of that, yes.
Now, we've covered the 2023 sampling, the 2024 sampling, and then pre-construction sampling, active construction sampling, and near-term post-construction sampling. Now, I'd like to discuss the WQMP's requirements for annual water quality sampling. Now, as you're aware, the WQMP requires Enbridge to collect certain annual water quality samples. Is that correct?
Yeah.
Now, for example, in year one post-construction, again, it's upstream and downstream samples at the same exact locations as before, correct?
Yes.
Again, that's every single water body crossing, right?
Yes.
Around 200 of them, right?
Yeah.
And now, obviously, you can't collect water samples if there's no water there, right?
Understood.
And the WQMP, in the event that occurs, requires Enbridge to conduct a second visit, correct?
Yes.
And during this year one post-construction sampling, the same parameters are to be analyzed as during the 2023 and 2024 sampling campaigns, correct?
Yes.
And that would be the table one parameters that we went through.
Yes.
The 30 plus chemical, physical, biological parameters.
Yes.
And now there's additional samples to be taken in year 2 and year 5 post-construction. Is that correct?
Yes.
Again, same location, same parameters as year 1, correct?
Yes.
Now, I just want to clarify, you understand that all the details that we've gone through, those only apply to waterway crossings, correct?
Yes.
The WQP actually establishes separate, specific protocols for water quality monitoring in wetlands, right?
Wetlands that would be to be crossed by the pipeline. right?
Yes, but you acknowledge there's separate protocols for those, correct?
Yes.
Now, the WQMP also requires Enbridge to submit annual reports to the relevant agencies, is that correct?
For the post-construction annual sampling, yes.
And the WQMP specifies the information that is to be included in these reports, right?
Yes.
Things like a summary of the monitoring conducted, right?
Yes.
And that would include dates, locations, methodology, and then the data itself, right?
Yes, typical reporting for a project.
Yeah. There's also a results section with a summary of findings, context for the data, and then relevant observations, correct?
Correct.
And the WQMP also requires this annual report to include a discussion section, right?
Yes.
And that includes identifying any notable water quality trends throughout the year, whether any state water quality standards were violated during the year, right?
Just to clarify that, you can't have a trend during a year at any one site, but the report would be including any site-specific across the years of sample.
Yes. My question specifically was about whether the discussion section requires Enbridge to note whether any state water quality standards were violated during the year.
Yes.
And as part of this report, each annual report, Enbridge also has to include the data itself, correct?
Yes.
And the laboratory analyses that were conducted,
Yes.
and the photos that were taken, correct?
Yes.
Now, the agencies that receive these annual reports, they then get the opportunity to review them and then pose comments and questions to Enbridge, correct?
Yes.
And the WQMP requires Enbridge to respond to the agency's questions.
Yes.
Now, one of these agencies is DNR, right?
Yes.
DNR is a state regulator, and they have oversight and authority over the project, right?
Yes.
So DNR, in each of these annual reports, they're going to receive data, all the data, and know exactly how Enbridge analyzed the data,
Yes.
and the methodologies that they use to analyze the data,
Yes.
and then Enbridge's conclusions that are drawn from that data.
Yes.
So, for example, you mentioned this morning Dr. Horn's methodology for calculating natural variability, and its specific focus on mean and standard deviation, which you allege is an inaccurate or inappropriate methodology, correct?
Yes.
Now, let's say, for example, in an annual report, Enbridge, does something similar. They make an error, they make an erroneous conclusion based on the data. All that data in its raw form is going to DNR in any case, and they will have the opportunity to review and use their own methodologies, correct?
In my experience, that's not something that the state regularly does, and it's up to the reporter.
But they have the ability to do
They
so.
have the ability to ask Enbridge to redo it.
And if they had the data itself, they would also have the ability to do it themselves.
And in my experience, that's something the state agency doesn't do. They ask the report writer or the project person
Okay,
to
so they-
redo that.
they can go back to
There's a
Enbridge.
comment response opportunity, yes.
They go back to Enbridge, say, calculated as please.
Yes.
Now, as we discussed, Enbridge has submitted the 2023 and the 2024 sampling reports to DNR, correct?
Yes.
And across 2023 and 2024, Enbridge has collected several hundred water quality samples at each specific water body crossing, analyzed them for that list of 30 parameters, right?
Yes.
But you're aware this isn't all the data that Enbridge and DNR have reviewed and considered in their analysis, right?
Yes.
As you pointed out this morning, they collected substantial historical data from a variety of waterways in the watershed, right?
Yes.
Now, specifically, the historical data was collected by 4 separate organizations for the most part, right?
Yeah, about that.
And there's DNR itself, right? There's the USGS, correct?
Yes.
The Great Lakes Indian Fish and Wildlife Commission,
Yes.
and then even from the Bad River Band itself, right?
Yes.
And as noted in the 2023 sampling report, these data are from 2010 through 2022, correct?
Approximately. Not every parameter is the same, but that's a reason.
Now, you're aware that Enbridge started this process initially by pulling nearly 400,000 records of data collected by these agencies, correct?
And total, for all of those parameters at all of those sites, it adds up, yes.
In total, they started with around 400,000.
Sorry, that's yes. Yes.
And these records were taken from 241 different sampling locations, correct?
Only Enbridge's samples were taken from this number of locations.
Well, the historical data itself, when you look at the 400,000 data points, that was from 241 sampling locations.
The historicals taken by the 4 different agencies,
Yes.
those were only a handful of specific sampling stations. There were nowhere near 240 different
Well,
locations.
I'd like to turn to exhibit 830, page 18. And you can see that first sentence under section 9.2 notes that original data from this document included 241 sample locations, correct?
As I'm reading it, it says after reviewing the available sample locations and data from 20 were selected to be summarized. And it's my assumption that you might have 241 sample locations, but you might have 1 sample or 3 parameters from some of those that were not sampled frequently at all. So it looks like the 20 locations were selected based on their proximity to the proposed project workspace.
That's correct, yes. I was going to get to that point that we started with 400,000 data points from these 241 locations. Then Enbridge filtered the records in order to get to the most appropriate, streams that are being crossed by the water bodies, and that would be approximately 20 streams, correct?
Yes.
And that includes streams like the White River, correct? Deer Creek, Marengo River, they're all listed in this document, right?
Yes.
And by narrowing down to those 20 water body crossings, they were able to get down to about 28,000 data points, correct?
Across parameters that are available, yeah,
For the 20 water
over
bodies.
10 years ago.
Now, as you're aware, Dr. Horn prepared an expert report in this case, which we discussed this morning, right?
Yes.
And you reviewed his report, right?
Yes.
And his report, as you noted, analyzed a variety of anticipated project-related impacts on an array of water quality parameters, right?
Yes.
And this, as you've discussed this morning. Surface water temperature is one of them.
Yes.
Dissolved oxygen is another.
Yes.
pH.
Yes.
There's a whole host of them. Now, as you're aware, his analyses incorporated the 2023 data,
Yes.
as well as the 2024 data,
Yes.
and then the historical data that we just discussed.
Yes.
Now, I'd like to introduce Exhibit 304, page 48. Are you there? Now, this is a table that Dr. Horn put together in his report, and it includes, it notes the number of data points and where they were taken from, correct? If you look at the bottom left corner of the table, do you see that?
Which one are you referring to, the Enbridge sampling or the statistics from historic?
So, yes, in the statistics for historic data, you see there were 889 dissolved oxygen data points considered there. You look at the,
Oh, I'm sorry, I'm on TKM on page 48.
are you referring to the base stamp number in the bottom corner? Because there might be a mismatch.
No, my mistake, yes.
No worries.
Okay. Yes, now I'm on dissolved oxygen.
And as you can see, there were 889 statistics of historical data, correct?
Yes.
As well as 164 from 2023 site-specific sampling,
Yes.
and an additional 306 from 2024.
Yes.
Now, you raise a criticism in your testimony, and you state that Dr. Horn failed to note that there are currently no data regarding anticipated project-related impacts. In your own words, there's only speculation. Is that correct?
For a project-related impact.
Correct. There's no data for project-related.
There's no active construction data. Yes.
And you go on to say that while Enbridge and its consultants like Dr. Horn modeled potential project-related impacts, the models themselves are not data.
Correct.
And again, this is somewhat of a simple point, but I think it's an important one nonetheless. There cannot be data for the projects that haven't happened yet.
Correct.
Instead, modeling, like the modeling that Dr. Horn performed, is really the only option.
Yes.
Now, as you testified this morning, part of Dr. Horn's analyses of the various water quality parameters involved the calculation of each parameter's natural range of variability, correct?
Yes.
And Dr. Horn calculated these natural ranges by looking at the hundreds of site-specific samples in 2023 and 2024, as well as the thousands of historical data points in 2010 through 2023, correct?
Yes.
Now, I'd like to quickly confirm your understanding of the analyses that are included in Dr. Horn's report. Now, obviously, we just established that he calculated the natural range of variability for each parameter, right?
Across the watershed. Yes.
And his report also quantifies the anticipated project-related impacts for each parameter.
As modeled for those parameters that were modeled, or yes.
Not each one had a specific quantitative,
No.
but a lot of them did.
Several of them. Yes.
Now, for example, petitioners and their experts have raised claims that clearing trees in the right-of-way will reduce vegetative cover and increase the amount of sunlight hitting the stream's surface. Is that correct?
Yes.
And this increased sunlight may lead to increased surface water temperatures, right? And Dr. Horn's report notes that the maximum increase in surface water temperature from this vegetative clearing is approximately 0.018 degrees Fahrenheit. Correct?
Based on the modeling that was done,
Correct. That's a calculation.
it bases on an estimation.
But nowhere in your report or your testimony do you refute this calculation.
No, I don't refute it.
In fact, nowhere in your report or testimony do you refute any of the calculated project-related impacts, correct?
I did not give any weight to them. No,
You didn't discuss them at all in your report or testimony.
not the models themselves, no.
Now, I want to confirm because there may be some confusion here. You're not taking the position that Dr. Horn simply compared these anticipated project-related impacts to the natural range of variability and then concluded that, so long as the impact is within that natural range, that there is no violation of the state water quality standard, correct?
I'm saying that watershed-wide variability is not relevant to site-specific variability, and that was not written anywhere.
Apologies, could you repeat?
It was my testimony that the variability of any one parameter across the watershed is not relevant to potential events at any one site, and the variability is going to be different at any one site. That was my testimony.
I'm asking if you are aware that Dr. Horn's analyses were not as simple as simply taking the project-related impact and comparing it to the natural range of variability, and if it was within that natural range, that he then just concluded that there's no state water quality standard violated.
I do not recall him referring any discernible impact to a water quality standard. He, as in my recollection, correct me if I'm wrong, he was stating impacts and changes during construction being non-discernible from watershed-wide variability.
So are you stating that Dr. Horn does not explicitly reference the water quality standards in his report or testimony?
In his statements of whether water quality impacts would be measurable compared to natural variability, he did not mention water quality standards.
I'd like to bring up Exhibit 376. This one's not in the physical binder, it would just be on the screen. Specifically from the page 20 to 21, sorry, page 4. Now you can see here that Dr. Horn is discussing the anticipated temperature increase of 0.018 degrees Fahrenheit, resulting from clearing of the right-of-way. Then Dr. Horn is asked on line 11, in your opinion, will the project cause a violation of DNR water quality standards for surface water temperature? And as you can see, starting on line 16, Dr. Horn specifically identifies the state water quality standards, correct?
I see that he's making a statement that any discernible difference is not going to adversely affect aquatic life. That's his opinion, yes.
But you're aware that you acknowledge that he is comparing the project-related impacts to the state water quality standard.
To the handful of parameters that were compared, yeah.
Can we turn to page 21 very quickly? Actually, can we turn to page 25? again, you can see here that Dr. Horn, starting on line 12, is asked his opinion on whether the project will cause a violation of state water quality standards. This time it's dissolved oxygen. And you can see it establishes in his answer, he cites to the specific state water quality standard for dissolved oxygen. And then if we can flip to page 26, can you see that Dr. Horn is comparing the anticipated project-related impact of 0.01 milligrams per liter to the state standards?
Again, it's a modeled potential impact, not actual, and it's speculation based on his opinion that it will not.
But again, you acknowledge that Dr. Horn, his methodology is not as simple as taking the natural range of variability and then simply comparing the anticipated impact to the natural range of variability.
It's my opinion that his report is focusing on the natural variability across the watershed to compare or make a statement about site-specific impacts and then generalizing that to a water quality standard.
And he compares each calculated impact to the applicable state water quality standard.
A calculated or modeled impact for several parameters.
Now, turning back to Dr. Horn's calculation of the natural ranges of variability, as you testified this morning and throughout your written testimony, you allege that Dr. Horn inflates these calculations, correct?
Yes.
And one of the ways he does this, as you testified this morning, is by relying on data that are not normally distributed.
He relies on the average and standard deviation in describing data that is not normally distributed.
And as we saw this morning, you created histograms in order to help illustrate your point here, which is marked as Exhibit 118E. Is that
Yes.
correct? I'd like to bring up Exhibit 118E, specifically starting on page 172. Now, if we scroll down on page 172, we can see the example that you went through this morning about the normal distribution curve, correct?
Yes.
And now Dr. Horn calculated the natural range of variability for numerous different water quality parameters, right?
Yes.
Your histograms focus solely on TSS and temperature, is that right?
The ones that I created from data were specifically meant for examples of skewed data or seasonally affected data.
Now, if we flip to page 174, these are the data that you plotted in this histogram for close-ended solids, is that correct?
Yes.
And now, this morning, you pointed out that there's several outlier data points, correct?
Several extreme data points. Yes.
Extreme data points, the ones on the right side of the histogram, correct?
Yes.
And as you stated this morning and in your testimony, these data points at these higher measurements are likely attributable to specific events, right?
Yes.
Such as a large storm event.
Possibly.
Now, to confirm that these data points are data points taken from things that actually happen
Correct.
in the real world.
Yes.
And they happen relatively regularly. I mean, just last month in parts of Wisconsin, we had a pretty large rainstorm, right?
Yes.
And now again, my question is, even if these are extreme data points or statistical outliers, they still reflect naturally occurring events.
Correct, but extremes and where the typical data fall as part of variability, they are two different concepts, and the water quality monitoring plan does not specify how data is to be interpreted.
Correct, but in the reporting requirements, DNR is going to receive the data, and they'll be well aware of, data points aren't normally distributed, correct?
They can make comments in the press changes, yes.
And it's pretty, as you testified this morning, it's pretty common to know that TSS and temperature are not normally distributed parameters, correct?
Correct.
Now, I'd like to turn our attention back to WQMP and some of your more specific concerns with the plan. In your testimony, you contend that the WQMP lacks described data quality objectives and criteria, is that correct?
Yes.
But just to confirm, the WQMP itself does in fact state its objective, right?
The overall objective in a general way, that's, yes.
And I'd like to introduce Exhibit 829, page 170. Specifically section 2.3. And please confirm that section is titled Data Quality Objectives and Criteria, correct? So,
Correct.
and it states that the overall purpose of the surface water quality sampling for this project is to monitor several analytes prior to, during, and after the construction period to maintain the quality and integrity of the water body and allow it to return to its original pre-construction nature after construction activities are completed, correct?
That's the stated objective, yes.
Now, again, to clarify, you're not taking the position that the WQMP lacks any stated purpose, correct?
No.
Instead, you simply think that this stated objective is deficient, as like in your report you note monitoring of a water body does not maintain the quality and integrity of a water body, and that monitoring does not allow a water body to restore to its original pre-construction nature. It can only document the events. Is that
Correct.
Now, I just want to confirm, we're talking about the water quality monitoring plan, correct?
Correct.
And you're aware that when it comes to restoration, Enbridge has provided TNR with a separate plan when it comes to restoration.
Right, this is the water quality monitoring plan.
Now, you also testified that the WQMP lacks criteria to which sampling results will be compared. Is that correct?
Yes.
And as we discussed, the determination that DNR must make before issuing a water quality certification is whether they have reasonable assurance that the project will comply with the applicable state water quality standards. Is that correct?
Yes.
Now, I'd like to return to this document here, a couple sentences. Later, please confirm that the document states sample results will be compared between upstream and downstream locations and will be compared to state water quality standards, correct?
Where is that?
This is the first paragraph under section 2.3.1, the last sentence.
Yes, I see that sentence.
So it's true that the WQMP does establish that the sampling results will be compared to the applicable state water quality standards. That's what we just read, correct?
Correct, but the sentence above that is different. The sentence above that talks about each particular site, parameter, increase, decrease, or remain similar.
Yes, but your testimony was that, well, for most of the parameters listed in WQMP, there's no criterion to which the results will be compared. Is that correct?
Yes.
And
There
this,
are no water quality numeric criteria for a good number of the parameters that are being monitored.
correct, but again, you testified earlier that Enbridge should not just erect a numeric equivalent to these qualitative standards, right?
May I make a clarification?
Yes.
It's my testimony that the water quality monitoring plan and quality assurance project plan lack specific decision data objective level criteria for deciding upon which there is a significant difference for any of the parameters on any water body in order to determine whether the parameter increased, decreased, or remained the same according to construction impacts.
Yes, I'm just trying to confirm that the change explicitly states that these samples will be compared to the state standards.
For those parameters that have a numeric. Yes.
Does it say just numeric state standards?
No, but as you said, many of them don't have numerics.
So is your testimony that you just cannot compare a sample to a non-numeric state standard?
No, that it's then based upon whether there's a significant impact upon construction at the site based on increased or decreased or significant difference. That's part of that consideration for a narrative criteria.
I'd like to turn to your testimony, both your written testimony and your testimony this morning and throughout this cross-examination. Now, first you allege in your testimony that the water quality certification requires Enbridge to monitor water quality to support a determination that the project would not cause an adverse impact to water quality. Is that correct?
Yes.
Can you please point to me where in the water quality certification it says that?
Can you pull up my report? It's listed.
Your report is
Is it in here?
that document.
Which one is it?
It's exhibit 102.
Oops, sorry. I believe there's several different certifications that relate to this, but the one that I have stated in my report is certification number 12. That you shall maintain the pipeline in a manner, and I'm considering construction for that, that ensures it does not cause deleterious impacts to waterways, wetlands, or groundwater.
Okay. My question is, what about that permit condition relates in any way to water quality monitoring?
There's only one way to determine if you've made an impact, is it's to monitor. That's why you're monitoring, correct?
Now, you're focused on adverse impact to water quality, correct? That's what you testified to here. That's what the water quality certification requires, correct?
That's a major part of it, yes.
Now, you also testified that Enbridge plans to define an adverse impact in relation to a significant difference in sampling results. And you've also used that term significant difference numerous times this morning, as well as during cross-examination.
As written in the water quality monitoring plan.
Now, could you please point to me exactly where in the water quality monitoring plan the term significant difference is used?
Give me a moment. There are several different statements in the water quality monitoring plan where that takes place, in terms of comparing data. I believe the construction is probably construction activities, probably sampling is probably the best if we go to that section and monitor.
Okay, my question is primarily focused focused on the fact that you use quotation marks throughout your testimony to use this term, significant difference.
It is specifically written in the water quality monitoring plan in several locations.
Yes, but in your testimony itself and in the report, there's no citation provided. And
Oh, okay.
so I'm not sure where it comes from.
Oh, we can find that relatively easily. Given
Well, it is an 830-page document.
Yes, if you go to this construction section of the water quality monitoring plan, pretty easy. You can also do a word search. Cannot do a word search for a document as right now. Maybe someone else can, or
Well, my question is, it's used so prominently throughout your testimony, and you quoted it so many times today, that I'm concerned with your inability to find it in that document.
Objection. That's not a question, and we're not, I think it's inappropriate for council to comment on his concerns.
I'll withdraw that. No, I request that we take our lunch break now, if that works for you. This is good time.
the conclusion